Hi guys, this is Shyam and welcome back to Engineering Hub. This is a place where you learn new things every day, and if you're working in an automotive sector or manufacturing industry, then this is a place where you can learn new things. And I'll be giving you more updates about the process and about the documents. What are the things that are required to survive in the automotive industry? So today we're going to talk about a very important concept. It's called PPAP. So PPAP is most basically a set of documents, and it's like if you're giving a separate if you're giving a product to a customer, then these are the requirements. These are the basic requirements. After that, you are qualified to supply all the products which you are going to produce. So if you're a supplier, then if you're going to give to your client whether the product, so this process you need to qualify, and after that only you can qualify as a supplier, and you can do mass production, and after that you can give a continuous supply of the product. So what is the PPAP? So PPAP is the full form of PPAP is production part approval process. As you can see, I'm just going to write down everything what I'm going to say, though, so that you can have a clear picture. You can have a clear idea of what I'm trying to say. Okay. So basically in PPAP, there are like 19 important documents. So 19 basic documents, and apart from that, there are some customer requirements. Those they have like 21 documents and all. But 19 basic documents is the set of that those are the mandatory documents. Okay, so we're going to see what are the mandatory documents one by one. Just going to give a simple. I'm not going to be. I'm not going to drag too much. I'm just going to simple objective of what are the documents are. So you can just go through and you can just follow. Okay? So the first document. Okay, the first document is the drawing. So basic drawing of the product. Okay, let me just write it down for you. So drawing or the design records. So the first document of this PPAP file, the PPAP file is called the design records. That's the drawing of the product. So drawing can be either from the customer side or the client side, or the supplier can make their own drawing, but it has to get approved from the customer. So it's basically the bible of the part. So basic the drawing is called the design records of the PPAP. Okay, the second level we're going to the second document is called the engineering change document. So what is the engineering change document? Okay, just let me write it down for you first. Okay, the second document is called engineering change document. So engineering change document is basically like if you have a revision level in this drawing, or some machine changes, some tool change, some dimension changes has happened, then those dimensions can be reflected in this document. So that is basically any changes in the drawing. It's called the engineering change document. And the third is called customer engineering approval. So in case there is a change of material, or some input has been given to change the drawing, then those things has to be added in the engineering. It has to be certified from the customer. So that document is called customer engineering approval. Okay, let me just write it down for you. Okay, the third document is called customer engineering approval. So whatever any changes in the drawing, it has to be verified from the customer, or any grade change or any source change, it has to be notified to the customer, and the customer has to verify that okay, we can proceed with this source change or this grade change. Then you can that document is called basically the customer engineering approval. So after that, the fourth document as the main document is called design FMEA. So design FMEA is like the failure modes that have been produced during the drawing condition. If you are going to give a part, and if you are given the drawing of that part, and what are the design issues that we are going to face? What are the failure modes? As a design team, from the design team, you have to check what are the design issues regarding with that component. So those things are covered in that design FMEA. Let me just write it down for you. I'm not going to brief everything about this. I'm just going to give a simple outlook, simple definition, simple one-word answer for everything. So you can just have that key points in your mind. So I'm just going to give a key points of this one. because if I start explaining everything, then it'll take a really lot of time. So what I'm going to do is I'm just going to explain to you a simple what are the documents available here, and what are the key points that you need to remember. And after that, I can explain each by each document what are the requirements. I can in a separate different video. Okay. For now, I'm just going to a simple outlook for what are the documents available and what are the key points. Okay. So the fourth one is called design FMEA. So like I explained, and the fifth one is called process flow diagram. Okay. So let me just write it down for you. So I hope it's visible right now, guys. If it's not visible, then just let me know. So process flow diagram is what is it basically? It's called a process flow of the product. What are the process that has been required to manufacturing the product? Okay, if you are producing a stamping part, then if it's a sheet metal, then there is a forming process, there's a bending process, and after that there is a riveting process. So it's a step of process from receiving stage. What are the condition, what are the process that are that is going to produce the part. Okay, from receiving the parts that you receive, the raw material it has to be received, and after there is an inspection of the raw material, and after that you're going to feed the raw material to the machine, and the basic operation of the bending and the stamping, those things are happen. So it's just put down in a format of a layout, like just like a line diagram. So that line diagram is called the process flow diagram. So process flow diagram is basically like the process flow which is involved in making the part. Okay. So this is the fifth document of the PPAP. So next document is called let me just write down first and I'll just get back to it. Okay. And the next document is called process FMEA. Okay, so as I've explained to you before, that design FMEA. So design FMEA basically the failure modes that are available in during the drawing condition, and so similarly the process FMEA is what are the failure modes that is available during the process, making the process of the during the process of the product. So if there is a separate stage of stamping, there is a separate stage of inspection. What are the failure modes that can occur in an inspection stage? What are the failure modes that can occur in the stamping stage? And if you're making a drilling operation, if you're making a separate bordered operation, then what are the failure modes that can occur in that process? You need to list down that process, list down the failures that can happen in that process flow, process FMEA. So, okay. So basically, I'm just going to explain you everything regarding, but the key point of what is a process FMEA, that I'm just going to tell you. Okay. So the thing is, the failure modes of a process called a process FMEA. Okay. The next one is called a control plan. Okay. So the control plan is basically what it is. I have explained to you that the process flow diagram is the process. I mean, if you're making component, then you have what are the process involved, and what are the failure modes involved. Then, if there is a failure modes involved in making a process, then what is the control to control that failure modes? Suppose there is a dimension variation, or suppose there is an there's no checkpoint in for the raw material. So what is the control for the checking of the raw material, and what is the control, how do you control the dimension variation of a product? If you're making this marker, then you should make sure that these two mating parts fit properly. Okay. So if there is an variation in the dimension, if there is an oversize or there is an undersize, then this may not fit properly. So you have to make sure that these things align. So there is an internal tolerance here, there is an external tolerance here. You should make sure that these two things correlate with each other. The tolerances are fixed in such a way that this mating happens properly. Okay. So these things, and what are the control that is provided in each process, those things have been recorded in the control plan. Okay. So the control plan is the seventh document of the PPAP. So next stage document we're going to see is the dimension results. So dimension results is nothing but the the dimension of the product. You have you have made the process flow, you have made the failure modes, and what are the, you have identified the failure modes, and you have also identified the control methods, and you finally you have made a product. What is the condition of the product? So what is the length of the product, what is the dimension of the product, what is the width of the product, and it's basically like a layout of a product. So suppose as a drawing is given, and you need to check all the dimension of the drawing, and it's being put down in a report. That is called the dimension report. So dimension report, it's called basically it's called a layout expense report. So these things are like if you have a rubber part or injection molding part, then you have like cavity wise separate parts are there. So you need to take what is the cavity wise, what is the uh, dimension, and what is the performance. No, you have to take all the things which are available in the drawing, and you have to put that here in a report format. So that's called a dimension report format. Okay. The next one, the next document is called a material performance test result. Okay. So let me just write it down for you. Okay. So material and performance test results is basically the chemical and the mechanical testing properties. Like if you have to test the durability, if you have to check the condition, the what is the mechanical condition, what is the tensile strength, what is the compression strength, what is whether that product can withstand the requirement of the customer, or whether it can withstand the material requirement. If you have made it in a metal, the metal whether it can withstand the chemical condition, because the product gets exposed to various atmospheric condition and various load conditions. So you have to make sure that the product survives in those conditions. So for that, this material and performance testing has been conducted. So basically these things have been set out in documents. So documents, they have like test reports. So either it's made internally, if you have the facility you can check it within your plant, or it's not available, then you can go for a third party also. So most of the time we go for a third party, and most of the companies, because you have to make sure that it's most costly to install this testing facility inside the company. So most of them opt for a third party. They have a third party agencies for testing these things. They have like servicing products or like that. So these servicing agencies, what they do is they test the product, and they test for the mechanical and chemical properties, and they give the results. So those things are called material and performance test results. Okay. So next thing, it's called an initial process capability study. Okay, let me just put down that for you. Okay. So this initial process capability study is the process study. Like you must have heard of the term SPC, statistical process control. So it's nothing but if you produce a product, so you have to take like 50 readings or 25 readings of that part, and you have to see how the process has been how is the process been controlled, how the part has been controlled, what is the control of the dimension, how the dimension of the part varies. So you have to take like the readings of the part, and you have to check what is the condition of the process. So it's like the CP value of the product, and you can validate whether the process is stable or not. For that condition, this process capability study is being conducted. So during initial there is a separate process study, and during the running condition there is a separate process study. So I can go in depth into it, but it's a very big topic. So I'm just going to give a key point of this one. So basically, it's to check the process capability. How is the process capability, and what is the condition of product using a 15 numbers or 100 numbers. So you have to check the 100 numbers, 15 numbers reading. So minimum is 15 numbers. So 15 numbers, you have to check the readings of all the dimension, what are the critical dimensions that are available in the product, and what as per the drawing. So you make a reading of those parts, and you plot a format, you plot a chart regarding that, the bell curve diagram. You need to compare those things. Okay, there's a CPK and CP value, so it should be like above 1.6 and above 2. So I'm just going to give a detail about in a separate video. Okay, so right now just a simple explanation of what are these terms and what are these documents. Okay, So the next document is called, okay, the next document is called MSA. So MSA is measurement system analysis. Okay, let me just put down that for you. So this MSA study is conducted to check the condition of the instrument and the appraisal. So appraisal, in the case the manpower. The manpower is using the instrument. Suppose if a manpower is using an instrument, so there's a B manpower. Suppose Ramu or Ramesh. So Ramu checks the products, or product or the dimension. He measures the parts and he has a separate value. Okay, so Ramesh checks the products and he has a separate value of that dimension. So, what is the comparison between these two operators? Those who are checking these two manpower, what is the comparison between them, and what is the effect of the instrument? So, where the product lies, where the issue lies, and what is the difference between the checking method of this? And this is basically to compare the measurement system. So the where is how the metal, how the instrument varies with the operator, how the variation between the operator. So these things are like conducted in the MSA study. It's basically like reproducibility and reproductive. So these two things. So you have to check whether there's a manual error and whether there's an instrument error. So that study is conducted using this MSA. So in while regularizing this MSA study, there is like three stages of this are there. Like one in bias, linearity, and stability, like three stages. So bias, linearity, stability. It's like for the bias, what is the biases? To check the difference between the reference value and the actual value which you're getting. It's called bias. And linearity is stage wise. What is the difference of the actual value in a various stage? Suppose if you have a vernier caliper, the range of the vernier caliper is 0 to 150. So what is the actual dimension value in the various stages, in the various ranges? Suppose 0 to 10 what is the actual value, and from 10 to 20, what is the actual value, and from 0 to 50, what is the actual value? So that variation is checked in the linearity study. And stability is you have to check the same variation in a period of time. Suppose you're checking in the monthly, like from January, what is the condition of that variation, and what is it in February, what is the condition, in March, what is the condition. So that is called stability. And MSS studies basically like for two types of instruments. So one is called the attribute study, and another is called variable study. So for variable instrument, we have a separate study called R&R. So R&R is if you're using a vernier caliper, if you're using a micrometer, then you have to like when you're measuring the part, the display will be there and they'll show the reading. Okay, what is the reading of the part? And if you're using a micrometer, then also it shows the reading. So that reading you have to plot in a series of 90 readings, and you have to use three appraisers, three persons you have to check. So you have to check the correlation of these three things. These appraisal. What is the difference? Where is it's a basic like a set of formulas where you have to you can check whether the measurement system is capable or not. So that is called the R&D study, and there is a separate study for this attribute gauges. Attribute gauges in the sense are like go-no gauges. Like you just have to take a part and you have to just there's a gauge will be there. You just have to insert that part and you have to check whether it's okay or not. There is called a snap gauge is there. So snap gauge is basically for checking the external dimension. So if I need to check this external suppose I'm having a snap gauge, means it'll be like a profile will be like this, and you just have to insert it here. So there will be go side and there will be no go side. So the go side it will be like you have to make sure that it enters inside, and the no go side how it will be, it doesn't go inside. So that's called an attribute gauge. So there is a kappa study for that one. So these things are covered in the MSA study, and they have a separate set of documents for this one. So this MSA study normally involves the instrument which are used in the control panel during the control of the process. So these things are carried out in the MSA. Okay. So these are the major documents till now which we are going to see in PPAP. And the next one, I hope there's much space here. So, okay, guys, should I continue? Okay, fine. So the next document is called the bulk requirements. Okay, so I hope there is space left here. Yeah. Okay, I'm just going to write it down. So not an issue. Okay, fine. So, so before bulk requirements, there is one more set of documents. It's called qualified laboratory documents. Okay. Okay. So qualified laboratory documents. So what is the qualified laboratory documents? Suppose if I'm using a vernier or using a micrometer, so these things are being calibrated by an external agency, or maybe the internal agency also. So what are the requirements of the agency, or whether they have the scope to check the dimension, whether they have to check the instrument, whether they are capable enough to validate, whether they have the scope to validate. So these things have been these things come under the qualified laboratory document. So this basically involves the scope of the document, the calibration certificate, and whether third party is capable of checking such things, whether he has the scope to check the instrument. So these things come under the qualified library documents. Okay, I hope the space is enough, right? Should I carry on here? Okay, right? No, no issue. Okay. So sorry, guys. Um, Let me go to the next document. It's called bulk requirements. Okay. So bulk requirements basically for the paint parts and the raw material, and though for those things these requirements are being made. So if you're not sometimes it's not applicable to most of the clients. So just for if you're getting a whole lot of paint, so what is the requirement for the paint, and what is the shelf life? So these things come under this bulk requirement. Okay, so the next one is called appearance approval report, or AAR. Okay. So appearance approval report. So appearance approval report is basically like what is the visual aesthetic things you need to check. What is the customer requirement? The customer has given a requirement to check the appearance condition. What is the appearance wise? What are the defects available? You need whether what are the conditions that you are going to check in a visual appearance stage. Whether you're going to check if it's in a rubber part or if it's a plastic part, then you're going to check for the streaks mark, for the scratch marks, because the major thing it'll be like the aesthetic part of the product. You are going to assemble in a car dashboard, and you're going to assemble in your steering system, and if you're driving the car and if you're going through the dashboard, you can see a scratch mark, you can see a white streaks like thing, then it'll be a little discomfort for you. So these things have to be monitored, these things have to be checked, and these things have to be put down in an appearance approval report. So those comes under this AAR, appearance approval report document. Okay, fine. And the next one is called I think I don't have much space here. I'm just going to rub this one. Okay, I'm just going to almost 14 things has been covered. So the next set of documents I'm going to write down in a different way. Okay, I'm going to just make it sure. So we just move on to the next one. The next one is called a sample product. Okay, so if you're manufacturing this marker, okay, so you have already made it. You have all gone through the dimension, and you have gone through the performance testing. So now you have to make a sample. So you have to, like, this is a sample that we have produced, and you have to get us a sign off. Okay, this is the sample. It is like this is the first sample we have produced. So you have to make sure that from your side, the customer may have given you a sample from some, but from your side you have to make a sample. So that's called a sample product. And another one is called the master sample. So master sample is basically you have made the product, and you have, as per specification, you have done everything, So you have to get sign up from the customer. Okay, this is the perfect product with all the dimension, with all the specification. It's being done perfectly, and you can declare that sample as a master sample. You have to make a separate identification for that one, and you have to put tag or something like that. So whoever you can whether if you have a concern in the future regarding that product, if there is a dimension variation, then you can refer to that master product. So that is called the master sample of product. Okay, so the next one is called the checking aids. Certainly, like checking aids. So what is the checking aids, and what are the instruments that you're going to use to check that product? So let me give you an example with this marker itself. So this is round in shape. Okay, so what are the things that I'm going to check because it's round in shape? So I'm going to check the diameter of this product. So diameter you can check using the micrometers. Okay, so micrometer and vernier, and whether you're using a scale to check the length of the product. So these things come under the checking aids. So what are the instrument? These are the instruments that are used to check the part. So those things comes and checking it. It's a different set of format, and this it's given like what are the instrument that are being used, whether the instrument has been calibrated, what is the range of the instrument. Those things comes under this checking aids. Okay, so the next one is called customer specific requirements. So what are the customer specific? The customer might have given a specific dimension control, or he might have added something from that must have been from his requirement. Suppose Hyundai is or you are going to supply a part to Hyundai, then they might have given a separate specification, separate control points. They might have there is a specific requirement of pass through characteristics. So these things comes under like some dimensions, some critical dimensions which the side of part which goes to mating condition in the customer end, which you don't have sub assembly here, then you have to go and assemble at the customer end. So those things has to be inspected in a stringent way. So if you're having a like check point of only 5 numbers for during delivery, so you need to check 100%, or you need to check like 100 numbers of those sample before dispatch. So these things are given from the customer side, and you need to follow them. What are the customer requirements? They given normally a format, and you have to ensure that these things are followed. That is called the customer specific requirements, or the CSR. And the last one is called the PSW. So PSW is the major document of the PPAP. So PSW is like a signed copy of this. It's like a contract of between the supplier and the customer, that you're signing off. Okay, I'm going to obey whatever you have given the requirements. I'm going to make sure that these things are being followed, and basically what kind of documents I need to submit to you if you are coming from our side to inspect and do audits at our end. So these things are covered in the PSW, the part submission order. So this is the basic and the major document in the PPAP. So the PPAP, the PSW is submitted in the front of the PPAP, and other documents are submitted later. Okay, so these are the major documents that are covered in a PPAP, and these things have need to be followed before you're going to for mass production. If you're going to supply like 1 lakh components or 50,000 components per year, I mean, if you're going to supply continuously, then these documents has to be submitted, and it has to be signed off from the customer and from your side, and it's like a mutual agreement between both the parties. So I hope you have had a clear picture of a basic idea of what are the PPAP and what are the documents are. In the next video, I'm going to show you what are the basic requirements, what are in each document, what are the requirements are there. So I hope you have learned something from this, guys, and if you have any queries, if you have any doubt regarding this one, and if you are not you need a more clarity ways, then you can just put it down in the comments. I can make sure that during my next video I can make a more elaborate video regarding this all these documents. And I hope you have learned something from this, guys, and do subscribe my channel if you really like this video, and if you want to keep my video for the future reference, then you can just definitely share it on your timeline, and do like if possible. And thank you for watching this video, guys. This is Sham signing off.